number and today we are here to start the matrices topic eigenvalue and eigenvector. First of all, what is the eigenvalue and eigenvector? Okay, so let A be the square of matrix order n if there exists a non-zero column matrix X and scalar lambda such that A of X equal to lambda X. Then lambda is called eigenvalue of A and non-zero column matrix X is called an eigenvector corresponding to lambda. The eigenvalue are also known as characteristics roots or latent root or spectral values of proper roots. Now Ax equal to lambda x. So we say that Ax equal to lambda Ix where I is a unit matrix. A minus lambda x equal to 0. So eigenvalue and eigenvector as the matrix A minus lambda I is called the eigenmatrix or characteristic matrix. Now determinant of A minus lambda I is called an eigen polynomial or characteristic equations or polynomial. It is polynomial of order n in lambda. The equation determinant A minus lambda I is called the eigen equation or characteristic equation of A. The root of determinant A minus lambda I equal to 0 are called the eigenvalue of matrix A. Now property of eigenvalue. First of all, the sum of the eigenvalues of a matrix is the sum of its principal. Okay. Diagonal elements trace of A. The sum of the eigenvalue of matrix is the sum of the principal diagonal element. That means we say that it is trace of A. Second property. The product of the eigenvalue of matrix is the determinant of the matrix. And the eigenvalue of triangular matrix, upper triangular, lower triangular and diametrix are the diagonal of the matrix. Okay. So, the eigenvalue of two matrix A and transpose of A are same. The eigenvalue of A raised to minus 1, that means inverse, are the reciprocal of the eigenvalues of the A. That means we say that if lambda is an eigenvalue of matrix A, then 1 upon lambda is an eigenvalue of matrix A inverse. Again, 6. If lambda is an eigenvalue of matrix A, then lambda raised to k and the eigenvalue of the A raised to k, where k is an integer. If lambda is an eigenvalue of matrix A, then lambda plus or minus k is an eigenvalue of A plus or minus ki, where k is an integer. If lambda is an eigenvalue of matrix A, then k lambda is an eigenvalue of ka, where k is an integer. Note, matrix A and A raised to transpose, that means transpose of the matrix, need not have the same eigenvectors. Now characteristic equation of the matrix. The characteristic equation of the square matrix A order 2 is given by lambda square minus s1 lambda plus s2. Lambda square minus s1 lambda plus s2. So what is our s1? S1 is a sum of the principal diagonal element of A. What is our S2? It is determinant of A. Now, the characteristic equation of square matrix A order 3 is given by lambda cube minus s1 lambda square plus s2 lambda minus s3, where s1 is a principal diagonal element of A, trace of A, s2 is a sum of the minor principal diagonal element of A, and s3 is a determinant of A. Example, if A 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3, to find the eigenvalue of the following matrices. Now we have two following matrix, that means A raised to t, A raised to minus 1, A square, 5A and A plus 2y. Solution. First of all, we consider a matrix A and characteristic equation is determinant of A minus lambda equal to 0. Minus lambda minus 1 1 minus 1 5 minus lambda minus 1 1 minus 1 and 3 minus lambda equal to 0. This is our characteristic equation or determinant. Now lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So what is our A? We are replacing s1 sum of the principal diagonal element of A. That means trace of A. So we are taking 3 plus 5 plus 3. What is the trace of A? It is 3 plus 5 plus 3. So we getting it is 11. Now sum of the minor or principal diagonal element of A. What is our minor? First is 5 minus 1, 1 minus 1, 3. Then 3, 1, 1, 3. And last one is 3 minus 1, minus 1, 5. It is our principal minors. We getting value as 36. Now what is our S3? Determinant of A. Determinant of, we get 3, 5 into 3 minus 1. So we get in 5 minus 1. Minus 1 minus 1 plus 1. Minus 1 into 3 minus 3. Minus 1 into 1, it is 1. Plus 1, 1 minus 5. So we get answer as 36. Now put the all values in equation, in characteristic equation. We getting lambda cube minus 11 lambda square plus 36 lambda minus 36. So we get the value of lambda. Lambda equal to 2, 3 and 6. Eigenvalue of A equal to lambda 2, 3, 6. What is the eigenvalue of A raised to T? That is lambda. It is also 2, 3, 6. For the A inverse, as per the property, we say that it is 1 by 2, 1 by 3 and 1 by 6. For the A square, as the property of A raised to K and lambda raised to K, we say that it is 4, 9, 36. Because it is 2 square, 3 square and 6 square. 5A, we are multiplying with the constant with the lambda or eigenvalue. We are getting 10, 15 and 30. And last one is A plus 2i equal to lambda plus 2, 4, 5, 8. Okay. Now another example. If A equal to 1 minus 1, 0, 2 minus 1, 0, 0, 3, find the eigenvalue of matrix A. Solution. We are getting A matrix of upper triangular. Eigenvalue will be element of principal diagonal. So elements are, eigenvalue is 1, 2 and 3 using property. Example, find the eigenvalue and corresponding eigenvector for A. 8 minus 6, 2, minus 6, 7, minus 4, 2, minus 4, 3. Solution, the characteristics equation given by lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Where s1 is the sum of the principal trace of matrix 8, 7 and 3. So we are getting 18. Sum of the minor diagonal using sum we are getting 45. S3 is determinant of A. To solve the determinant we are getting the value 0. So the characteristic equation is lambda square minus s1 lambda square plus s2 lambda minus s3 equal to 0. We get lambda cube minus 18 lambda square plus 45 lambda. So we get lambda square minus 18 lambda plus 45. Answer is lambda minus 3, lambda minus 15 equal to 0. So we get lambda equal to 0, 3 and 15. Eigenvalue is 0, 3 and 15. Now we will find the eigenvector for the corresponding eigenvalue. First we take lambda equal to 0. E minus lambda ix equal to 0. In matrix we are putting value. This is our matrix. Okay. So A minus lambda, we are taking lambda equal to 0. So we get 8 minus 6 2, minus 6, 7, minus 4, 2, minus 4, 3, x, y, z, 0. So 8x minus 6y plus 2z equal to 0, minus 6x plus 7y minus 4z equal to 0, 2x minus 4y plus 3z equal to 0. The equations formation. We have solved two equations using Cramer's rule. We get x by 10 minus y by 20 plus z by 20. So x, y, z divided by 1 by 2, 2 equal to t1 we are supposing. So what is our vector? A vector is t1, 1, 2, 2. We say that it is x1. Now x1 is an eigenvector for the lambda equal to 0. Corresponding value. Now we have to find for lambda equal to 3. Taking a minus lambda ax equal to 0 in matrix or characteristic equation, we put lambda equal to 3. We getting 5 minus 6, 2. See, it is 8 minus, we put here 3. So 8 minus 3 it is 5. 7 minus 3 it is 4. And 3 minus 3 it is 0. So we getting a new matrix, and comparing with the equation, we get 5x minus 6y plus 2z equal to 0. Minus 6x plus 4y minus 4z equal to 0. 2x minus 4y plus 0z equal to 0. So taking first two equation and using Cramer rule, we get x by y by z, 16 minus 8 minus 16. So our second vector is 2, 1 and minus 2 for the lambda equal to 3. Now we find the lambda equal to 15. Put the lambda value in the matrix again. We getting different matrix for the minus 7, minus 6, minus 2, minus 6, minus 8, minus 4, 2 minus 4 minus 12, and x, y, z equal to 0, 0. Now converting to equation formation and using Cramer rule, we get x, y, z minus 20, minus 20, minus 10. So our third eigenvector is 2 minus 2, 1 for the lambda equal to 15.